Hi, in this lecture we are going to explain application of z-transform. After we learn how to find z-transform of a sequence and how to find the inverse of z-transform using partial fraction and long division, let's apply what we learn in some application. Some application here are written like how to find the system impulse response, and usually we call it h of z. That's the impulse response in z domain, and how to find the difference equation that relates the input of the system to the output, and how to find the response to a given input. Let's explain this concept using one numerical example. In this example, let's assume that we have a linear time invariant system has impulse response h of n, and the input is x of n, and the output is y of n. The question is, find the impulse response h of z in z domain. To find that, we have to convert everything to z domain, so x of n will find the equivalent x of z, and this one will be h of z, and the output will be y of z. So the impulse response in z domain will be equal the output divided by the input. That's, h of z. But it's already, if it's given h of n, and in this problem is given, if it's given like this form, for example, that's given in the problem. And we want to find h of z, so that will be an easy task. All what's supposed to do, find the z-transform of h of n. So write h of z is equal to the impulse here, that z-transform is equal to 1, and the step is equal z over z minus 1. How we found this z-transform? Using the table. There is a table in the handout, has all transforms, z-transforms. And let me point out something. Sometimes you'll find in the table this is written in different form, written as a power of z minus 1. You can get it if you multiply the top by z minus 1, the bottom by z minus 1. So z power minus 1 times z will be equal to 1 over z minus power minus 1 to the z multiplied by z will be equal 1 minus, and 1 times z minus 1, z minus 1. That's another form. Both are right. This form and this form. You can work with either one, which form that you feel comfortable with. Okay, so we should simplify the expression. So write h of z equal to, you have to find common denominator between 1 and z minus 1, that will be z minus 1, and 1 multiplied by z minus 1, z minus 1 plus z. So the final answer will be equal to 2z minus 1 over z minus 1. That's h of z. Again, if you want to express h of z in different form, in terms of z to the power of minus 1, you can do that. All what you're supposed to do, look for the highest power for z. You find z power 1 is the highest one, right? So multiplied by z power negative 1. If the highest power was z squared, you multiply the top and the bottom by z to the power minus 2, okay? So that's just very simple. In this example, it's really easy because the highest power is z power 1. So multiply the top by z to the power of negative 1 and divide by z to the power of negative 1. If you do that, so the impulse response will be equal to z to the power of minus 1 times 2z, you get 2, that's it, minus Minus 1 times z minus 1 be z minus 1. Okay, the bottom part, z times z minus 1 be equal 1 minus z minus 1. That's another form. Both are right. One expressed in the terms of z and the other one in terms of z minus 1. So that was the first part. So just to remind you, the first part that was given, the impulse response as a sequence, and it was required to find in z. Let's go to the second part. The second part is find the system input, output, difference equation. What does it mean? It means the system has input x of n and has output y of n, and they want to find the equation that relate the output of the system to its input in terms of n. And it's called difference equation. Let me remind you, when you study in other courses that deal with continuous time system, that was like x of t and the output was y of t, then you can describe the relationship between the output and input by differential equation. As example, like you can find maybe dy of dt, that's differentiation of the output, like say plus 4y of t is equal to x of t. This differential equation express the relationship between the output and input when the system is continuous time system. Now we don't have that, we have discrete. So when we have the discrete system, we have x of n and y of n, and we want to find the difference equation that relate the output to the input. How can you do that? Well, there are many ways. There is one way you can find the relationship using h of z. We found h of z. Here you go. This expression or this expression. Well, let me choose this one. So it's equal to 2 minus z minus 1, 2 minus z minus 1 divided by 1 minus z minus 1. All right. And we know that h of z, the transfer function or the impulse response, that's equal to the output related to the input. Okay. From this relationship, we can find the relationship between y and x. How we'll do that? Just cross multiplying. So you will say that y of z multiplied by 1 minus z minus 1 equal to x of z multiplied by 2 minus z to the power negative 1. Now let's solve it here. 1 times yz will be yz minus z minus 1 y of z equal 2x of z minus z minus 1 x of z. So this equation, it's in the domain. Difference equation should be function of n. It means you have to find the relationship between y of n and x of n. That's the difference equation. So obviously we have to convert each term from z domain into n domain. How we do that? There is an important property that's going to help you in z-transform. This property said that if you have a signal x of n and you want to find z-transform, you can call it x of z. If you have x of n shifted by alpha, so you will have z to the power of minus alpha times x of z. That's a very important relationship. Don't ever forget it because you use it all the time. I'm going to apply these rules to this equation. Y of z, the inverse, is equal y of n. minus z power minus 1 y of z. I'm going to apply that property where alpha is equal 1 because I have z to the power of negative 1. So you will have x, we have here the y, n minus 1 equal to x of z will be x of n minus z minus 1. It means x, and n will be minus 1. What I have here, that's the difference equation that relate the output to the input. Similar to the differential equation, but we don't have differentiation. We just have shift in n one time n minus 1 and so on. So that's the difference equation. All right. And by the way, if you have the difference equation, you can get h of z, the impulse response from this equation. You convert this back to y of z and x of z and divide y of z by x of z and get h of z. It's like, you can make the reverse process. All right, let's take another requirement for the problem. Okay, see, now let's assume that the input is a step. If xn is equal to unit step in this problem, so what's y of n? It means find the unit step response. It means find the output when the input is unit step. All right, and it's given h of n and h of z. Well, to solve this problem, you got two options. You may operate using convolution or working with z. Z is much easier than working with the convolution. Convolution in z, it's easy because you know that y of z is equal h of z times x of z. So the convolution in z is converted into multiplication, which is easier to deal with. All right, do we have h of z? Yes, we do. Then you will ask, okay, I have two forms of h of z. This is any one I said it can work, right? All right, let me take the one in the top now. 2z minus 1 over z minus 1 as h of z. 2z minus 1 over z minus 1. That's h of z. Times the input x of z. It's a step. So you got to go to the table and look for the step. What is z transformation of the step? It's equal to z over z minus 1. Or again, I'm going to tell you, or maybe you find it like that. Both are the same. Since I'm working with the positive power of z, I'm going to take this one. Z over z minus 1. Now, I just simplify it. I have z minus 1 square. And the top part, z times 2z minus 1. What is that? Y of z. Well, great. Don't think that you got the output that they ask for. They ask for the response. It should be y of n. But you have y of z. What should you do? Just use inverse of z transform. That's all. Well, how you do z-transform? We did that in previous lectures. Use long division or partial fraction. Of course, long division is not practical in this problem. Just use partial fraction. How you do that? Let me refresh your memory. First, you have to divide by z. So you have y of z by z will be equal to 2z minus 1 over z minus 1 squared. Then you make the partial fraction. Remember, you have to look for the case in your hand. Is it simple roots, repeated roots, complex roots? Well, we have repeated roots. So what should you do? Say z minus 1 squared, the highest one, and then start to minimize the power till you reach the last one, power 1. Call this constant k1, call this constant k2. How to find k1? K1 will be equal to the same function here, but without the denominator, it means 2z minus 1, and substitute by z equal 1. So 2 times 1 is equal 2, minus 1 is equal 1. So k1 is equal 1. That's the first one. Let's find k2. How you find k2? You take this guy and differentiate with respect to z. And after you differentiate it with respect to z, substitute by z equal 1. Well, differentiate 2z minus 1 will be 2. Okay, that's very simple. So you got k2. Now we substitute by k1 and k2 in the equation of y of z. So you will say y of z over z is equal k1, which is equal 1, over z minus 1 square plus 2 over z minus 1. Then multiply by z both sides. Why? To get y of z. So y of z is equal z over z minus 1 square times 2z z minus 1. All right. So now what do you have? Well, you have the y of z as we found out from partial fraction. Okay, so now you look for the table and try to find out the inverse. So you will have y of n equal this one. If you look at the table, find it's equal to the RAM n un, and this one will be equal to, and z over z minus 1 is the unit step. So the response yn is equal to n plus 2 un. So that's the response, and we answered the question. Okay, you can check your work using MATLAB as we explained in the previous lecture. Well, there is another input, but I think I will take it in another video, and just let me tell you what we are going to do in the second video. We are going to have input, and this time this input is going to be cosine omega n. All right, it will be like sinusoidal function. So that will be in the next section. Thank you.